This is G485 homework booklet question 12. So we've got a sample of a radioactive isotope, and it's got that number 4.5 times 10 to the 23 active undecayed nuclei, and we've got a half-hour half-life. So we've got to calculate the initial activity. So straight away I'm trying to calculate activity. I've got number, so that brings to mind A equals lambda n. What we haven't got, really that should be A naught equals lambda n naught. What we haven't got, however, is lambda, but we have got half-life, and it's really important that we remember that if we've got half-life, we can very easily calculate lambda and vice versa, just using that half-life times lambda is 0.693 natural log of 2. So I'm just simply work that through. Lambda therefore is a 0.693 divided by 12 times 10, 12 times 3,600, and we get to that value, 1.604 times 10 to the minus 5. This then becomes trivial, putting it through, and we end up with 7.22 times 10 to the 18. It asks for the number of active nuclei after 36 hours. Now I could go to A equals A naught e to the minus lambda t. I've got lambda, I've got t, I'd have to put it into seconds, and that would work just fine. However, they've been nice here. They've told me it's 36 hours, and I know it's a 12-hour half-life, so that's 3 half-lives. That means I've got, after 1 half-life there's half, after 2 half-lives there's a quarter of the original, after 3 half-lives we're at an eighth of the original. So all I need to do is actually to take this number, the 4.5 times 10 to the 23, divide by 8, and I end up with 5.6 times 10 to the 22. And then the number of active nuclei of the isotope after 50 hours. Now I could have said, well, 50 is 50 divided by 12 half-lives, and then multiplied that original number by a half to the power 12 over 50. But I thought, my feeling was that in this case it was easier to go with the full A equals A naught e to the minus lambda t. So there's A naught, there's E, there's minus lambda, and there's the t, 50 hours times 3,600 seconds in an hour. And we end up at 2.5 times 10 to the 22. And then finally we've got to explain why the activity of a radioactive material is a major factor when considering the safety precautions in the disposal of nuclear waste. And essentially what they were after here is the fact that whatever the value of lambda, and essentially therefore the activity, that has different safety implications. So if lambda's high, that means that I'm going to have a high initial activity, and that means I've got a high initial activity, and that makes it particularly dangerous in the short term. And of course, if I've got a very low lambda, that means it's going to remain active for a long time, because the half-life is therefore long. It's going to remain active for a long period of time, and therefore I've got issues around long-term storage. So whether lambda's high or low creates its own problems. So that was G485 homework booklet question 12.